Look at that jagged line. Look at the jagged line. What is this jagged line? That jagged line is a velocity. A velocity. Okay. An object is moving along a line. It's not that line, guys. It's not moving along this jagged line. That's not what it's talking about. It's moving along like a line like this, just back and forth on a line. Okay? That's what it's talking about. The following graph gives the object's velocity over time. And so the object is changing speeds over time. It's still staying on this line, but it's changing speeds on that line. Okay. For each point on the graph, is the object speeding up, slowing down, or neither? Okay. I want to start you guys off. No, yeah, I'm going to... I'll tell you guys how I think when I look at this point right here. You see this point right here? Is that point, at that moment, is the point getting closer to the x-axis, or is it moving away from the x-axis? Because if I'm getting close to the x-axis, wouldn't that be losing speed? That would be losing speed, right? So I look at that point and I'm like, oh yeah, this point right here for sure is slowing down. Okay. Why? Because it's getting closer to the x-axis, so it's slowing. This is one way to think about it. I'm going to show you guys another way to think about it, because depending on what kind of problem you're solving, one way is easier than the other way. Okay. So this one right here. Now, I see it I think they're trying to be like on the points right at the bottom. So we're assuming right there at that point, we're no longer moving away from the x-axis, but right now we're starting to move towards the x-axis. Okay, but it's like at that instant where we're changing from moving away from the x-axis to going towards the x-axis. So would that be speeding up, slowing down, or neither? And the answer is neither. Okay, my other way, guys, will make this easier to explain. But look at this point right here. That one right there. Is that one moving towards the x-axis, or is it moving away from the x-axis? It would be moving towards it. So that would mean it's slowing. Now we have this last point right here. Is it moving away from the x-axis, or is it moving towards the x-axis? Away. And when you move away, that means your speed's increasing, right? So that means we are speeding up. Okay, and that's how I would do it. And so on Khan Academy, when you guys touch these points, it gives you those three options. You have to select the correct option, blah, 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 blah. Now, what's the other way we can use to understand these? And this is valuable, guys. I know some of you guys are going to look at that and go, oh, I like the other way. I'm not even going to think about that. Don't do that. You got to know both, okay? Trust me, it's helpful. Because we're going to be talking about this concept right here until the end of this semester. So check this out. At each point, we have a velocity and acceleration happening. Okay? So we're going to talk about this point first. We have velocity and we have acceleration. Now, right now, on the velocity graph, that means all these y numbers right here are velocity numbers. We can look at those numbers, the y numbers, and know if the velocity is positive or negative or zero. All right, that's very important. So at this point, is the velocity a positive number or is it a negative number? I mean, that's kind of an obvious question. It's like at 2, right? And that's positive. So I'm going to say velocity is greater than 0. It's positive. All right. I could also write positive if I wanted to write it like that instead. This is just a better way to write it because you'll use this way to write it in the future when you guys are doing free response questions. If you want to say something is positive, you would say it's greater than 0. Now, what about acceleration? That one's kind of weird. Now, how do you get acceleration? Well, if you guys had a position function and then you took the derivative of it, you guys know what that is? That's velocity. And if you took the derivative again, you guys know what that is? That's acceleration. So, and this guy is the slope of this guy, right? That's how he's related. And then this guy is the slope of this guy. You guys see that? You kind of understand that? Okay, so if acceleration is the slope of this velocity right here, what is acceleration? Is acceleration positive or negative? Look at the slope of this line right here. Is it positive or negative? Is that positive or is that negative? It's negative. It's going down. So we're less than 0, which means we're negative. You guys got that? Now, here's the rule. You can say whenever the signs are opposite, you're slowing down. And it makes sense, too, when you consider it. If your signs are opposite, you're slowing down. If you currently have a positive speed and your acceleration is negative, that means you're slowing down. Signs are opposite. Signs are different. So here's my notes for you guys. Signs different means slowing. Okay, so let's do another one. Let's see. This one right here. My velocity, acceleration. Is my velocity positive or negative? Come on, Stews. Positive. So we're greater than 0. So I'm going to write positive also for you noobs out there. And what is my acceleration this time? Is this slope right here positive, or is the slope at that point negative? It's positive. So we have similar signs. The signs are the same, which makes sense actually. If you guys are driving in a car and you're going forward and you are accelerating, wouldn't you be going faster? Oh my goodness. Yes, Mr. Patey. So I'm going to say speeding right here. And that's what we said earlier. We said this was speeding with our other way of interpreting. Now, we have one more scenario, and that's this one right here. I'm glad it was on here. Velocity and acceleration. Is velocity positive or negative here? Or I guess it could be neither, right? It could be neither, because velocity could be right on the x-axis. And right here is negative. Velocity is less than 0. It is negative. Okay, but here's the weird one. Acceleration. Acceleration. We're right on the points. Now, you guys have done derivatives before. We're right on the points. Is the slope positive or negative? Trick question. Right here, acceleration does not exist because you're on a point. Remember, a function is not differentiable on a point or a cusp. So we have D and E. So what happens when we have a sine and a D and E? It's neither. And it will always happen like that. Okay? If the acceleration is if the acceleration does not exist, or if the acceleration is 0, you'd be neither. If velocity does not exist or 0, it would be neither. If you're doing one of these graphs, here's another type of question. If you're doing one of these graphs and it's not asking you about speed, but it's just asking you something like, is the particle moving forward or backwards? That has to do with the sign of velocity. If velocity is negative, then you're going backwards. If your velocity is positive, then you're going forwards. If it's neither positive or negative, then obviously you're not even moving, right?
So, I guess like